Hello and welcome to yet another video. Today we have something very special. This is my very first AM5 board that I've gotten. And the big problem with AM5 board is that most of these boards have broken pins in the socket. But this one, luckily, is immaculate, which is why I got this one. Most of these boards that break are instantly going for warranty, so that someone sends them back and they're getting replaced. But this one was denied warranty because of some physical damage. And I can already tell you the physical damage is not the problem of this mainboard. Let me quickly show you the physical damage that this board has. And what you can see now is the proposed physical damage that caused this board to die. And if you have seen any of these videos, you know that this is not enough physical damage for this to die. So what I've also done is I went around the area to see if anything was knocked off or broken, but there's nothing here. So all that there is are these few scratches that you can see here, but there's nothing more. None of these traces are ripped. None of these are damaged. All of these, this is just the masking of the board by itself. There's nothing knocked off. I also checked the backside of this, but there was nothing. And interestingly enough, the seller provided another information, which is that it turned out that his CPU has also died that he put into here. And then he said that he doesn't know if the main board killed the processor or the processor killed the main board. So I was very curious already because of this is my very first AM5 board, and what I was able to see is that our 12-volt line, we have a short circuit on 12 volts, as you can see. So what we now need to do is to take this monstrosity of a board apart and see why our 12-volt line is shorted to ground. And now we've revealed the massive VRM on this board, which looks really impressive, to be honest. And these are DR MOSFETs in this case, instead of the high side low side MOSFET that we had many times before. And I think I can already see the problem. It was quite obvious which one. This time we don't need voltage injection. This time the MOSFET seems to have exploded again. So let me quickly show you that on a microscope. And would you look at that, we have yet another probably welded MOSFET. And what I instantly see as well is that that resistor is toast as well. So what we will need to do is we need to try to remove this MOSFET, which will be probably quite hard because this looks again like these layers burned here. If you've seen a different video of mine, you know how much I love burned layers on a CPU V-core. If you've seen the ASRock board, and if you look at this is just very light scraping. Well, the good thing is actually here, this looks like copper. Just clean copper, I mean. Because most of the time you just have charring. But this might be a healthy like ground layer or something. Very interesting. You can also see that the solder is greasing out of these sides here. So I can only imagine how hot this must have gotten at one point, because all of that solder is squeezed out there, because this is how it's supposed to look like, and that is how it looks like. So I will try to apply hot air into here. I will probably need to take this capacitor out because this is too close and this will require a lot of heat. So let me do that and try to get this out. So, okay, after using a lot of hot air, trying the soldering iron, we have lost some components, but they are not critical, or they might be critical, but I know I can look up what values these are, so don't worry about these. But I still cannot get this MOSFET off. This is so fused to the board. There was so much heat on this, and I couldn't get this off. So, I, for the very first time, will try to Dremel this off. So, I've never done that. I'm going to be experimenting a little bit around this, and I will be trying to Dremel it out. So now the Dremel is done, and I got to say I took off more than I wanted, to be perfectly honest. The Dremel was way stronger than I expected it to be. So I've taken a little bit too much of the masking off at some of the points here that I would have liked, just like here. Um, I think all of this is good though. This is the output. I'm not too sure if why we have such a break in between here. Um, I think this should be the output of the MOSFET, and this is then going to the face. But I really wanted to make sure that there's no charring anymore. And I have not confirmed if we still have it short on 12 volt or not. Yeah, you can see this pad, for example. This is not as much as I would have wanted. This is not optimal. This is not optimal, as you can see here. This probably should have been connected to there. This one should be connected to here, is probably still connected. This goes there, this goes there. This one doesn't go anywhere there. This one goes there, I believe. And then you have all of this pad connecting to here. There's a via there. And you see that there's nothing supposed to be here. There's a break in there, just like there. And this is should be all connected like it is right here. And yeah, I've also gotten that cap, I just realized. So this cap has to go, and I will also instantly remove this resistor. So, with now everything removed, let's go to our overhead cam view again. And now, let's see if we still have a short on 12 volts or not. I hope that we do not. I didn't see any other phases that looked awful, but I think this will be the only one. And thankfully, we have 10 kilo ohms and rising, as we would expect to have. So the big thing now is the question, does this board boot without that single phase? The big thing right now is, as of yet, I do not own DDR5 RAM, and I do not own a CPU for this, to be perfectly honest, because the cheapest CPU for this is a 7500F, I think. That's like 150 bucks. And the next cheapest one is the 7600X, which costs 200 bucks. And I would want the 7600 because it has an iGPU that I could use. And the another big problem is this takes DDR5 RAM. I do not own any DDR5 RAM. So far, what we're going to do now is we are going to be connecting power to this, and I would want to see if this board actually turns on without a processor in it. Back in the day, AMD didn't used to do that, and I want to see if it maybe does now. So let's find that out together. So now we have our power supply in here, and I'm very nervous for this. Let's see what happens, what we can see. And this looks very promising so far. This is almost 100 milliamps, which I would expect for a mainboard as passive power draw. Let's now connect a power button, and let's see if this starts. And I'm pressing the button and it doesn't start. Really sad. So AMD has continued with their way of having a lot of the processing, like the startup sequence on the CPU. So this won't start without the CPU in it. But this means we will see each other again, but probably only as soon as I have another processor, or if I have ever a processor for this, and I have DDR5 RAM. So today is the 20th of February. Who knows when will be the time when I have a CPU for the LGA 1718 socket, which is AM5. So it's been about 7 months, with that, really can't believe. But I've now finally pulled the trigger and gotten a Ryzen processor. This is a 7600. And this cost me a whopping 200 euros to buy, just for a processor to have for testing. There are no on the used market here in Germany. And the thing is, there are like 8400 Gs that you could get. But the problem with that is that not every BIOS would support them. So you would have to update a lot of BIOSes on these boards in order to make them work on here. So to have a backwards compatible, the 7600 that I got is the cheapest first release of AM5 that is out there, and we will be trying that now out here. For you, it's only been a second, but for me, it's been an eternity basically. And yeah, let's see if this will actually boot now with the one phase removed. So the 7600 is now in, and I've got VGA connected, or like in this case HDMI connected. Let's see for the passive power consumption. Oh, that is 5 volts. That is not the right output. Now we have 12 volts connected, and we have very low passive power consumption. Interesting. Oh, it is not plugged in. Oh, man. So we have now everything hooked up. Let's supply passive power consumption. 150 milliamps. That looks very healthy. Okay, let's get a speaker onto here and also a power button. So, and now let's get... I'm kind of scared to press this power button because of that drilled out face that we have in the top. So let's see what happens. And it starts up. Is this DRAM LED or is this a VGA? This is a DRAM LED already. So we have RAM training, I think. As far as I know, RAM training on like AM5 takes quite some while. It might also not be compatible with this RAM. This is AM5. This is DDR5 RAM. Oh, and there's boot, I think. We gone to the third LED and it's restarting. The power consumption looks very good on here. Let's see if we can get a post screen. If I can capture that or not. Do I have my post screen connected? But the question is it able to capture that with the capture card that I'm using? But it seems like we have 1.7 amps, but it seems stuck at some point. Can't really tell you where we are stuck. Let me see if I can turn this off again. Okay, it turned off. Let's try this again. So we do have the post LEDs. So we still at DRAM. Let's see. I think this is RAM training, yeah, and then we are at the different LED again. Then was VGA, and then it just turns off? Do we go into some kind of protection mode? It seems like it wants to go to VGA, but then turns off. This is very interesting. And then we're just stuck. So it feels like it goes into a protection mode because the VGA isn't running correctly. Because obviously we drilled out a whole phase. So let's see if it behaves any differently if we try to use an actual dedicated GPU. So let's see. So we're RAM training again. And now we go to the further LED. And let's see when we go to, yeah, the same thing happens. It wants to go to VGA, but then cannot. I wonder if we have voltage. Because this thing is just completely stuck as far as it seems. Let's see. We have 0.9 volts. So it's all present. But why isn't it posting? Like the CPU is definitely getting warm. Very interesting. Let me try some different RAM and maybe reset the BIOS. Because I don't think there's a fault detection here. Because it's just 0.9 volts. Just what I would expect there at the inductors. So let me get some different RAM in here. I've been told that a DDR5 RAM, especially M5, is really picky in terms of RAM. And can very often just behave weirdly. And it seems like the same behavior with different RAM. And now stuck again. Really weird how it wants to go to VGA and then cannot go further. But the power consumption still is jumpy, like it wants to boot up. Oh, this time it rebooted by itself. Let's see if this is actually going to work or not. So I've now connected my lab bench power supply instead of the DPS power supply that we have, because it might be actually current limited. I really don't know how much current AM5 takes, and that might have been our problem, that as soon as we go to VGA, let's see now if we can go further. Oh yeah, we were current limited. That's what was the problem. This is a hungry chip. That just draw like 7 amps. Okay, well then, yeah. Then our 5 amps that our power supply can give out is way too little. But we are stuck at, is this boot or VGA? Oh, I just don't have the picture. Why don't I have a picture? Because it does react to the caps lock. As you can see, that's the connected keyboard. And the system is definitely on, but I do not get a picture out of it. Very interesting. Let me turn that off once more. And let's try the internal again, the internal graphics of the chip. So let's see if that works or not. So let's see now. This time again, we are connected to the internal graphics. Let's see if we can... Ah, there we go. The internal graphics definitely worked. Interesting that the PCIe didn't work. But there we are. The board is actually working. That is great to see. Let's see a BIOS screen. There we are. Another BIOS splash screen. And let's see. I want to go into an actual BIOS. There it is. That is what I wanted to see. Very nice to see. And the CPU is at 84 degrees. Let's turn that off. But who would have guessed? 7 months ago, we actually fixed this board already. So drilling out that phase was enough for this board to work. And I won't be selling this board or giving it on, so I will leave it like that, because this will be my test bench for AM5 going further on from now. So that now I have an actual CPU and I have an actual main board that works. and I can fix AM5 CPUs going further in the future. And yeah, you could. I'm not sure if that phase needs to be replaced. I'm not too sure how power hungry these chips are and how well this phase VRM is built. But this VRM looks massive. This looks like this board would manage a processor like this without any problem. Like, not putting that phase back on, because actually trying to repair that would be kind of hard, because I drilled out a little bit too much of the masking, and we would have to put a lot of solder mask onto there and some of the passive components, and then put a DR MOSFET into there. But I think it would be even better to just not put one there and just use the board like it is. Like, I think I could daily drive this without a problem. Because, yeah, I don't think that this VRM is weak. I think this VRM is very, very strong. Like, maybe if you would go one of the top processors, it wouldn't be able to handle this on long term. But if the cooling is enough, which I think with these it is, because these are beefy heat sinks, I think this board would just manage with one phase less just fine. Like, to be perfectly honest. And yeah, this is my very first AM5 board that I was able to fix. It only took, what, 8 months to do so? But better late than never. And yeah, this will now go into my collection for testing, because I collect every single socket of mainboards, just to be sure to have one to test out different things. And this is my first AM5 board, and so it will go into my collection. Maybe at some point it will be replaced by a different, cheaper AM5 board. But yeah, so far I have this one, so far I will use this one. So thank you very much for watching. All of my tools are linked in the video description. Sorry that this is a scrambled video with like 7 months in between, but that's how it turns out sometimes, because I just wasn't ready to spend 200 bucks on this processor right here. But right now I had the possibility to do so, and so I did. And yeah, hopefully we will have great repairs going in the future with the AM5. Thank you very much for watching. All of my tools are linked in the video description. This was Mainboard Medic. Thank you and bye.